Welcome back. This is the second primary trig ratio lesson on finding angles. So just again, as a reminder, like I said in the last lesson, it's always best to actually write out SOHCAHTOA on top there, so you have it right in front of you while you're doing your homework, your lessons, a test, an assignment, anything like that. Okay, so obviously knowing SOHCAHTOA is only half of it. You need to know actually what that means, what that represents. So of course, sine theta is equal to O over H, which is opposite over hypotenuse. Okay, cos is A and H, so adjacent. Whatever's first is on top, whatever's second is on the bottom of that fraction. And lastly, we have tan, which is opposite over adjacent. Opposite over, oops, not hypotenuse, adjacent. All right. So for every trigonomic ratio, there is an inverse ratio. So we looked at this a little bit with those calculating skills on that last note. Okay, but we have an inverse ratio. So this inverse ratio is used to calculate angles. They are usually found on your scientific calculator by using the second inverse or shift key. And again, you should be familiar with that because we discussed it when we were going over how to use your calculators. Okay, so I said for mine, it's shift. You could also have second or inverse. Oops. Oh my goodness. So the inverse for sine is going to be sine -1 on your calculator. Inverse for cos is going to be cos -1, and lastly, the inverse of tan is going to be tan to the -1 there. Okay, so let's do a couple of examples of this. So it says calculate each of the ratios given, round to 1 decimal point. Okay, so anytime we see sine, cos, or tan, theta, or any sort of variable to represent your angle, and then a value on the other side of the equal sign, we are always going to be using this inverse function. Okay, and again, if you want to think about it as solving an equation, you can think of the opposite of sine as an inverse sine, the opposite of cos as cos -1. So just like we had to use the opposite of, say, multiplication, we would divide. It's the same sort of idea here. Okay, so in order to calculate these, we're going to get rid of the sign by taking the inverse sign of both sides. So we have sine -1 of 0.667. Again, you pull out your calculators, typing that in. You should end up with an answer of 41.8. And again, we're dealing with an angle measurement here, so we want to include that degree symbol. Okay, same thing with cos. So in order to get rid of that cos, to get theta all by itself, we need to take the inverse cos of both sides. Again, it's always best if you do this on your calculator as you're following along. You should get 48.2 degrees. And lastly, we're going to be using that inverse tan, so tan -1 of, again, that 0.667. And this time you should get 33.7 degrees. All right, so to find the measure of an acute angle, in a right triangle, it is necessary to have the measure of any two sides of the triangle. So in order to calculate for an angle, we need to have two side lengths, is all that sentence is saying there. Okay, whereas before, when we were dealing with sides, all we needed was one angle and one side length. To get the angle, we need to have two of those side lengths. Okay, so let's read these steps and then jump into some examples here. So there's 3 steps to solving angles. So the first thing, just like before, is we need to label the sides of our triangle relative to the angle you want. So again, that's important, right? The hypotenuse is always the hypotenuse, but those opposite and adjacent sides will change based on the angle that you're looking at. Okay, so that relative to the angle is very important. Step 2 is determine which trig ratio to use. So are we going to use sine, cos, or tan? And then these steps are essentially the same. The last step is to set up that equation and solve for the inverse trig ratio. Okay, so starting with step 1, let's look at A here. And you'll have it in front of you. Hopefully you have the note printed off. Okay, so we need to start by labeling our sides. So again, just to make it easier, you don't even have to write out even like HYP for hypotenuse. You can just call it H. So the one across from the right angle is always your hypotenuse. Okay, this is asking us to find angle C. So angle C is obviously our reference point, right? That's the angle we're trying to find. That's the angle we're going to use. So opposite of that angle is our opposite side, which means that this last side over here would be our adjacent side. Okay, so when we're finding an angle, it's even kind of easier to figure out the trig ratio because you need to include the two side lengths, right, that you're given, because that's what that stipulation said on our note above, that we need to have two sides of the angle, or sorry, two sides of the triangle to find the angle. So here we have the opposite side length and the hypotenuse. So obviously we need to use sine, right? So we are going to use sine here. So now we've determined which trig ratio, we can move on to step 3. So we need to set up this equation and solve. So I'm going to start by just writing out the general trig ratio, which is sine theta equals opposite over hypotenuse. Okay, again, this is just a good formality because then you know you're not going to make a mistake, right? I have a bit more room. Last time I didn't do it just for the sake of room, but here I have a bit more room, so I always want to write that out. Okay, the next step is to fill in the information that we know. So sine is never going to change. We don't know theta. We know our opposite side length is 6, and our hypotenuse side length is 11. Okay? So, 2 different ways you could do this. You could definitely just do 6 divided by 11 and get a decimal number there. Okay? Or you can leave that for the next step. So for me, I'm just going to leave it to the next step. So again, my goal here is to get theta all by itself, right? So what I need to do is I need to get rid of that sign. In order to get rid of that sign, what I'm doing is the opposite operation of taking the sine of something, which is to take the inverse sine of something. Okay, what I do to one side, I have to do to the other. Okay, on the left side, they will cancel out. So I have theta is equal to the negative sine, or the inverse sine of 6 divided by 11. Okay, or the fraction 6 over 11. Okay, again, for you guys, most people don't really like fractions, so you're probably going to want to just simplify that first. So on your calculator, you can just type in 6 divided by 11, and then click second shift, whatever button it is, to get you to that sine -1. You should get that theta is equal to 33.1 degrees. Okay, again, my calculator says 33.05, but it's asking us to round to 1 decimal point. Okay, 5 is obviously 5 or higher, so that 0 will become a 1. All right, moving on to B here. Change my color. So this time it's asking us to find angle T. So again, step 1 is always to label our sides. Okay, so we know across from the right angle is always the opposite. Okay, we are looking for angle T. That means that's our angle of reference. So we're looking for the one across from angle T. We're going to label that our, oh, look at me. I typed in opposite. I meant hypotenuse. Sorry, guys. Across from the right angle is always the hypotenuse. Across from the angle you're working with is always your opposite. And whatever's left over will be your adjacent. Okay, next step is to figure out which trig ratio we're using. Again, remember, this is even easier than the last lesson because we're just looking for the ones that we have information. Okay, so we need 2 side lengths. We can see we have our opposite and our adjacent, so we are going to be using tan. Okay, because tan is opposite over adjacent. Again, always helpful to write that out. Tan theta equals opposite over adjacent. Okay, next step is to fill in that information and solve for theta. So again, we don't know the angle, so theta is going to stay as our variable. Our opposite side is 4.5 centimeters, and our adjacent side is 6.5 centimeters. Okay, again, we need to get theta all by itself, so in order to do that, we need to take the inverse tan. So we have tan -1, 4.5 over 6.5. Okay, and again, you can definitely just do that division right off the bat, and then you don't have to worry about writing out that fraction. Okay, so we have, again, I like to do that first. So 4.5 divided by 6.5 should give you 0.6923. Your shift on your calculator or your second, using that tan inverse button. On my calculator, I get 34.695. Again, it wants us to round to just 1 decimal point. Obviously, 9 is higher than 5, so my decimal changes from 6 to 7. So you should get an answer of 34.7 degrees. Okay, one last example here. So again, this time we're finding angle M, but I need to start by labeling my sides. So again, opposite of that right angle is your hypotenuse always. Okay, opposite of the side we're looking for is going to be the opposite side. So we're dealing with angle M here. So the one across from that is this side here. And lastly, the one that is left over is always our adjacent. So this time when we're choosing our trig ratio in step 2, we need to have a trig ratio that involves the adjacent and the hypotenuse. Okay, so that is going to be cos. Again, you should see that because it's written on the top of your page there. Okay, so again, starting by writing this out, cos theta equals opposite, no, not opposite, adjacent. See, this is why it's important to have it written in front of you, because you might not always remember. So it's adjacent over hypotenuse. Okay, now I need information that I know. Theta is going to stay the same because I'm looking for that angle measurement. My adjacent side is 2 meters. My hypotenuse is 3. Again, to get rid of that cos, we need to take the inverse of cos. So we have theta equals cos -1 of 2 over 3. Okay, so theta equals, again, if you don't have an ABC button, you're probably better off to just do 2 divided by 3 equals. So 0.666666, just going to keep going. And then taking the cos -1 of that, you should get on your calculator 48.18. Okay, obviously, again, 8 is larger than 5, so we need to round that 1 up to a 2. So we have 48.2 degrees. as our final answer. Okay? And just as a good habit, what you should be doing now is just going back and making it obvious what your answer is. So just your little therefore statement, three dots, therefore angle C equals 33.1 degrees. Therefore, angle T equals 34.7 degrees. And lastly, therefore, whoops, that's not therefore. Therefore, angle M equals 48.2 degrees. Okay, again, just a good habit to get into to get all those communication marks. So this is the end of your second lesson on trig ratios, specifically on finding angles.